Okay, so we're going to talk about angle relationships. We have 1, 2, 3, 4, 5 angle relationships, and then we're going to talk about angle bisector again. We've already done bisector. That was in first unit. We did that vocabulary word, okay? So we're going to remind ourselves what that one is, and it should be pretty simple to go from there. Adjacent angles. I don't know. It depends on how far we get. Okay, so adjacent angles. Adjacent angles are angles that share an endpoint and a common ray. I guess I should have said a vertex. Endpoint, vertex. Remember, that's kind of interchangeable in an angle. Okay, so to illustrate that, I'm just going to draw an angle. I'm going to draw a ray that comes out the inside of that angle. This is angle 1. This is angle 2. They're adjacent because they share that vertex, that endpoint right there. And then this is the ray that they share. Simple for that. They don't have any mathematical relationship. Like, we don't know anything about adjacent angles are congruent to each other or anything like that. We just know that they share a side and a vertex. So for number 1, what angle is adjacent to angle 3? Angle 1. Because angle 1 shares a vertex right here. And it shares that common ray right there. Does that make sense? Okay. What angle is adjacent to angle ABD in number 2?
C.
Huh?
D.
Say it again. No, we got to do the whole angle name. DBC. Remember, we name an angle with 3 letters, and we follow it. 1, 2, 3. Okay, so do 3 and 4 on your own real quick. Okay, for number 3, Jose, what did you get for one of the angles that's adjacent to YZW? Remember YZW? Angle XZW. I think that's right. I just was being annoying. YZW, yes. Angle XZW would be one of them. I'm going to trace that one in purple because here's our vertex that they share, and then they share the side, ZW. Okay. Kenna, what is the other one that's adjacent? VZY. Because they share YZ, and then again that same vertex. Okay, pretty easy for this one so far? Alani, for number 4, what angle is adjacent to AFB? Those are the correct letters. I'm just going to change up the order just a little bit. Remember, we always go from endpoint to vertex and then to another endpoint. So BFC, they share that vertex and then that line, BFC. Okay, so adjacent angles we're good on? Not difficult really at all, right? Complementary angles. Complementary angles are two angles whose measures sum or add up to 90 degrees. Okay, so they could be just in a 90-degree angle. And I have two angles there that would add up to 90 degrees. Or you could have like that and then like that. And if I put those two together, we'll say this one is like 62 degrees. And this one is 28 degrees. Because 62 plus 28 is 90. Okay, so they don't have to be adjacent to each other. Oh, I just gave you the answer to number 1. I thought I was making one up. So for number 1, what's x? 62 degrees. My bad. Guess subconsciously I saw that. No, but thank you. Okay, so on number 2, we need to name a pair of complementary angles. So I only see one angle that's marked as 90 degrees. So what two angles are part of that bigger 90-degree angle?
BFC and CFD.
Okay, so BFC and CFD. Now, in your classifying maze, I'm getting a little ahead of myself, but it's okay. In the classifying maze, what did we say it was whenever it was a straight line?
90 degrees.
So if these two add up to be 90 degrees, what do that one and that one have to add up to be?
90 degrees.
90 degrees. So BFA and DFE, bless you.
Thank you.
Now I cannot mix and match because I don't get to assume that these are all 45-degree angles where I could mix and match which ones go together. But I know that these two add up to 90 because of the square. And then I know these two have to add up to be 90 because I know a straight angle has to be 180. Okay? All right, 3 and 4 have some algebra thrown in with it because you know you don't get away from algebra ever. So find the measure of two complementary angles if the measure of angle A is 7x plus 4 and the measure of angle B is 4x plus 9. So how do I set that up?
8x plus 5 equals 3.
You are on the wrong example. Number 3.
Oh.
What do I know about complementary angles?
It's equals 90.
They equal 90 degrees, so can't I say the measure of angle A plus the measure of angle B equals 90 degrees? Yeah? So then I can combine like terms. I've got 7x and 4x, 4 and 9. So what's 7x plus 4x? 11x. What's 4 plus 9?
15.
Equals 90 degrees. What do I do now? So 11x equals 77. And then what does x equal? 7. Okay, but that's not all it asked me to find, is it? It said find the measure of the two complementary angles. So for angle A, I'm going to do 7 times 7 plus 4. Oh, I don't know why I put an extra parentheses, sorry. 7 times 7 plus 4. And yes, what did I get for that? 53. Okay, then for the measure of angle B, I can plug 7 into what angle B is, but what could I also do? Subtract and and just say 90 minus 53 and get close 37. Okay, so now I want you to try number 4. Okay, so Aaliyah, how do I set it up? Plus 3x plus 8 equals 90. Okay, so my first step is combining like terms. Jessica, what'd you get whenever you combined like terms? 11x plus 13 equals 90 degrees. Maybe. Okay. And then I need to get my x's by themselves. So Lee, what did you get whenever you got your x's by themselves? Well, here, let me see. Yeah, so what'd you get for this step? That's what I meant.
Oh, 77.
So 11x equals 77. So hopefully everybody figured out what does x equal? 7. So it happened to come out the exact same as the last one. Okay? Disclaimer, I did not make these up. So it's not my fault that they all came out the same. Questions on complementary? Real quick, if you go ahead and turn the page, that's fine, but I just want to show you this cheesy way to help remember. Complementary, the C, if I add a line right here, now it looks like a 9, it's 90 degrees. Okay, super cheesy, but it might help you. So you take the C, add a line to it, and it becomes a 9, and then I add a 0, because the same thing's going to work here too. So supplementary angles are 2 or more angles. I'm just going to put 2 plus because my box is tiny. 2 or more angles whose measures sum to 180 degrees. So again, just like on complementary, they could be adjacent to each other, so they could form a line. And if they form a line, I know they have to add up to be 180. Or they could be separate from each other, so if I have this and then that one, and I'm going to make it different numbers this time. 152 and 28, because those would add up to be 180. Okay, so number 1, if those two are supplementary to each other, how do I find the measure of angle F? Just subtract it from 180. 180 minus 132 equals, so x is 48 degrees. Done. Okay, so take a sec and figure out 2 pairs. There's 2 pairs of supplementary angles on example 2. Figure out what those 2 pairs are. And then I'll ask somebody to help me with it in just a minute. So there are actually several pairs here. So I'm going to do it this way. Destiny, tell me one angle that if I put it with DEF, I get supplementary. Which one is supplementary to DEF? DE, not H, but G. DEG. Good. Because DEH would be that whole line. So while it is 180 degrees, I couldn't add them together. Does that make sense? Okay. And then let's do another pair. So Ashton, how about GEH? What would be one that is supplementary to GEH? FEH. And remember that little angle in front is how you label that it's an angle. I also want you to notice, so we did DEF and DEG. What about DEF and HEF? Do those work? Because DEH is a straight angle. Okay, so how about GEH and DEG? Do those work? Yes. Okay. So you could come up with 4 if you wanted to. If you want to write them all down, go for it. Number 3, find the measures of 2 supplementary angles if angle A is 3x minus 7 and angle B is 2x plus 2. Okay, so we're going to work through this one together. I'm just going to call on you for parts, so don't feel like, even though I didn't let you work it previously, it shouldn't be too bad. So L, what's my first step if these are supplementary angles? I want to set it up in the equation equal to 180. 3x minus 7 plus 2x plus 2 equals 180. So my first step is combine like terms. So I'm going to give you a second to do that, and then I'll ask somebody to tell me what they got for that. Okay, so Brenna, what'd you get when you just combined like terms? 5x minus 5. Okay, my next step, I have to move stuff away from the 5x, sorry. Move stuff away from the x. So, Kinsey, how do I move this over to the other side? Add it to both sides, so 5x equals 185. Perfect. Okay, so, Abby, what did you get for x?
Teachers and students at this time, if you are a band member, please report down to the main office area. Thank you.
Make sure that y'all check the video, check for the video of this, band people. Also, that assignment will have a homework check over on Monday. Okay, the rest of us, we're going to keep going. Vertical angles, because we should be able to finish the notes at least. Vertical angles, definition of vertical angles. 2 angles that share a vertex and are formed by opposite rays. So remember that opposite rays are 2 rays that share an endpoint and go in an opposite direction. So if I'm looking at number 1, or here, we'll do an illustration first. All of the illustrations look the same for this one, because if it's opposite rays, then I need to have opposite rays. So that means they form a line. And then another set of opposite rays so that I have some angles. These two are opposite of each other. These two are opposite of each other. And one more thing that we need to know about vertical angles. Remind me what that symbol means. Congruent. Vertical angles are congruent. Actually, I'm going to write it right next to vertical angles. Vertical angles are congruent. Okay? So if I look at number 1, remember they're just angles that are across from each other basically. Here. Not here. Just left. Goodness gracious. Oh my goodness. Okay, somebody give me a pair of vertical angles because it's giving me all the people that are gone. 1 and 2. Okay, so angles 1 and 2. What's the other pair? 3 and 4. So we're gonna skip number 2 because it's just the same thing again. Number 3. I need to find the value of x. So what did we just say about vertical angles? They are congruent. So how should I set up an equation for this one? One of them equals the other. That's it. 7 plus 13x equals negative 20 plus 16x. Oh my word. Okay, so what's my first step? Minus 16x, so I can move all of my x's to the left because I'm OCD with my equations. So what's 13 minus 16? Negative 3. That was right. So 7 minus 3x equals negative 20. And then what do I need to move? So 7. So minus 7 on both sides. Negative 3x equals negative 27. Divide by negative 3. So x is positive 9. Because it's a negative divided by a negative. Vertical angles, good, easy, no problem, awesome. Nobody answered, so I'm going to say yes.
Yes.
Okay, linear pair. Linear pairs are a special type of supplementary angles. It's adjacent angles that are supplementary. So that's the mathy term, or the mathy definition. They're adjacent angles that are supplementary. Okay, so the not mathy definition is a little bit longer, but I'm going to say it so you at least hear it. Y'all, it's just two angles that are next to each other on a line. It's linear, so line. I've told y'all that's not one of the only words I missed in a spelling bee, right? Even though I asked them for the definition and they said that it was on a line, and I still spelled it wrong. It's fun. So, L-E-N-I-A-R. I switched the I and the E, even though they told me it was on a line. And both my parents are math teachers, so I was really embarrassed whenever I missed it. But linear, it's on a line. Pair, it's two of them. Okay? So it should be pretty easy. Illustration for this, just like our supplementary, would be these two angles right here. Because they're next to each other and they form a line. All right? So angle 2, if they form a line, what does that mean that they have to be equal to? 180. I'm going to write that down just so that we remember. So for angle 2, what should I do?
180 minus 138.
Perfect. 180 minus 138, which gives me 42. So angle 2 is 42 degrees. Okay, this one says name all the linear pairs. That's because there's a lot of them. So I'm going to call on people, maybe, if it picks people who are here. Alani, what would be an angle that, for angle 5, there's more than one, what angle would make a linear pair with angle 5? 5 and 6 would, and 5 and 7 would. Perfect. Angle 5 and angle 7, yeah, I'll just do 7 first. Angle 5 and angle 6. Good. Lee, how about angle 8? 8 and 7? What else? Do you want to say it? 6. Angle 8 and angle 6. Oh my word. Okay. Did I miss any? No? I could do them in different orders, but that covers all of your linear pairs. Remember, 2 angles next to each other on a line. Okay, so example 3. Let's see. Not picking the middle people like at all. Madison, how do I set this up to figure out the measures? Good. Add them together and set them equal to 180. Equals 180. Okay, so my first step is combining like terms. When I combine like terms, Zaylee, what do I get? 12x plus 30 equals 180. Okay, my next step is to move stuff away from the x. So I need to move that 30 over. Elijah, how do I do that?
Okay, you subtract it from both sides.
And I get
150.
12x equals 150. Perfect. Okay, so for my last step, I'm just figuring out what x actually is. So Jessica, what do I get for x? 12.5. Does that sound right? X is 12.5. Okay, so we're not done because it asks for the actual measures. So remember, then I just go plug it in. 7 times 12.5 plus 20. What does that give me for LMO? 107.5. And then remember, for OMN, I could plug 12.5 in again, or what else could I do? Subtract it from 180. So I'm just going to do 180 minus 107.5, which gives me 72.5 for that one right there. Okay, I'm going to move my x equals just a little bit so that I have space to write on this next part. Questions on linear pair? Pretty easy so far? Last thing that we're going to talk about is angle bisector. Who remembers what a bisector is? Or what a bisector does? So whenever it was a segment bisector, it cut a line segment exactly in half. Okay, so if it's an angle bisector, what's it going to cut exactly in half? Cuts an angle exactly in half. Or into two equal pieces or something like that. All right, so for that first example that it gave me, it says we are going to assume, it didn't tell us this, we're going to assume that XB, ray XB, is a bisector, because that's the only way that we can figure this out. So ABX is 5x, and XBC is 3x plus 10. So what do I do? What did we say an angle bisector cuts it into? Cuts it in half. If it cuts it in half, then what do I know about these two? They're the same, so they equal each other. So how do I solve it? So 5x minus 3x gives me equals 10. And then what does x equal? 5. So x equals 5. Now, it does want me to find the measure of ABC. So pay attention because ABC is the whole thing. So where should I plug that in? I'm going to do it to 5x because it's the easy one. So if I do 5 times 5, I get, okay, if that's half of it, then what's the measure of angle ABC? 50, because I have to double it. Easy? Okay, try the second example. Hopefully the hardest part of this is just the algebra again. Like I said, it doesn't ever go away, but the concept should be pretty simple.
Hey, teachers, if you would, please release Cheer and Palm, freshman students. Thank you.
All that you're going to miss me say is the last example and then what they're going to work on the assignment. So you're good. Okay, so for this last example, Amaris, how'd you set it up? Perfect. 5x plus 18 equals 2x plus 12. Okay. Brenna, what's my first step? Move my 2x over. So I get 3x plus 18 equals 12. All right. Lee, what's my next step? subtract the 18. So I get 3x equals -6. Okay, and anybody, what did you get for x? -2. It is okay for x to be -2. It's not okay if I go plug this in that one of my angles comes out to be a negative number. But x being negative is fine. Okay? We're going to change what the problem says because I didn't read the angles. Did you just, yeah. So what it actually says, actually, I'm just going to work it out to the side. We're not going to go any further than that on this one, but I'm going to show you what this one is actually supposed to be because, oops, I didn't read the angle measures. This says the measure of angle ABC. So that's the whole one. And CBX is the half. So that's my bad because I didn't actually read that all the way through. So ABC is the whole, CBX is the half. So if I need to set this equation up, I'm going to say 5x plus 18, is that my whole or my half? Whole equals 2 times 2x plus 12. Because that's my half. Yes, ma'am.
Could you do like 5x plus 18 minus 2x plus 2 equals 2x plus 2?
Yes. Yes. You could do that too. Because that's only half of it. CBX is only the half. So they're equal because it's a bisector. So since they're equal, I can just multiply it by 2. So I get 5x plus 18 equals 4x plus 24. And then I'm going to subtract that 4x, which just gives me x plus 18 equals 24. And then subtract 18. So x is 6. So for all of the band people that had to leave, you can ignore the first part that we did because it was wrong. This is the correct way to do it. Then where would I plug that 6 in to get the measure of angle ABC? ABC, so you could plug it into 2x plus 12. Where would be the easier place to plug it in? 5x plus 18, because that's going to get me the answer without having to do any other work. So 5 times 6 plus 18 gives me 48 degrees. Okay? Questions on that? Sorry that I totally messed that one up the first time. I was just in the groove and going through the motions. Okay, say that again. No, that's all we are doing today. We are stopping there today. So now you have the rest of class to work on the assignment until